Dear students, in this class let us discuss about the different types of kernels. So, we know that what is a separable kernel. So, consider a Fredholm integral equation, that is g of x equals f of x plus lambda integral a to b k xt f of t dt or k xt g of t dt. Consider the Fredholm integral equation g of x equals f of x plus lambda integral a to b kxt g of t dt, where here kxt is said to be the kernel. We know that kxt is the kernel of this integral equation, and this kernel is said to be a separable kernel if this can be expressed as a sum of finite number of terms, that is sigma I ranges from 1 to n. It is a of x into ba of t. If kxt is expressed as in this way, then this kxt means this kernel is said to be a separable kernel. That is, it is said to be a separable only when it can be expressed as a sum of finite number of terms, and it is each term is the product of a function in x and a function in t. Now let us discuss another kernel which is known as an iterated kernel, which is called as iterated kernel. What is an iterated kernel? Iterated kernel means it is consider this Fredholm integral equation, either it is homogeneous or non-homogeneous. Then consider this k1xt. Here k1xt equals kxt. Then k2xt. Here k2xt equals, it is k2xt equals integral a to b kxs into k1st ds. K2xt equals integral a to b kxs k1st ds. K3xt equals integral a to b, it is kxs k2st ds. Then like this, what is knxt? It is knxt equals integral a to b, it is kxs kn minus 1 st ds. Then these kernels are said, this knxt is said to be an iterated kernel where n equals 1, 2, 3, etc. This is called as an iterated kernel with respect to the given Fredholm integral equation. If it is a volatile integral equation, if the given integral equation is a volatile integral equation, then here k1xt is kxt, k2xt equals integral a to b, instead of b it is x, integral a to x kxs kst ds, and knxt equals again integral a to x kxs k1st ds is this only in case of volatile integral equation. So these kernels are said to be an iterated kernel. Now the third one is, it is a resolvent kernel or a reciprocal kernel. A resolvent. It is a resolvent or a reciprocal kernel. What is a reciprocal kernel or a resolvent kernel means, consider this Fredholm integral equation g of x equals f of x plus lambda integral a to b kxt g of t dt. Then the solution of the integral equation is given by g of x equals lambda into integral a to b rxt lambda f of t dt. This, if g of x, consider this integral equation, Fredholm integral equation, g of x is f of x plus lambda integral a to b kxt g of t dt. If the solution of that integral equation is g of x equals lambda integral a to b rxt lambda f of t dt, then this rxt lambda is said to be, it is the resolvent kernel or reciprocal kernel. And we know that the separable kernel is the finite sum, but the resolvent kernel rxt lambda is given by integral sigma m ranges from 1 to infinity lambda power m minus 1 km xt, where km xt is an iterated kernel. Km xt is an iterated kernel that is obtained as in this way, and Rx t lambda is sigma m ranges from 1 to infinity lambda power m minus 1 km xt. So this Rx t lambda is known as the resolvent kernel, or it is the reciprocal kernel. Okay. Now let us try to find out the solution of a Volta integral equation or Fredholm integral equation by the process of the iterated kernel, or in terms of the reciprocal kernel or resolvent kernel. That is our next aim. Okay. So for that, consider an integral equation. Consider an integral equation. It is g of x equals x plus integral 0 to 1 by 2 g of t dt. Consider this integral equation. Solve this integral equation by the iterated or reciprocal kernel. G of x equals x plus integral 0 to half g of t dt. Clearly this is a Fredholm integral equation. Why? Because the limit of integrations are constants. A and b equals 0, b equals half. Here what is lambda? Here when you compare with the standard Fredholm integral equation, we know that lambda equals 1 and the kernel kxt is also 1. Lambda f of x equals, and what is f of x? F of x equals x. Here f of x equals x, lambda is 1 and kxt equals 1 when it is compared with the standard Fredholm integral equation. Okay. Then for the iterated kernel, what is k1 xt? We know that kxt equals 1. So k1 xt equals kxt. So it is 1. Agree. K2 xt. K2 xt. What is K2 xt? K2 xt equals integral a to b. It is kxt. So kxs into kst ds. K2 xt equals integral kxs k1 st ds. So that equals integral a to b, means it is integral 0 to half kxt. Kxt is 1, so kxs is 1. Kst is again 1 because it is constant, so 1 into ds equals s from, that is integral 1 ds, that is integral 1 ds is s from 0 to half equals 1 by 2. So k2 xt equals 1 by 2. What is k3 xt? K3 xt equals again integral a to b, means 0 to half kxs. It is as it is kxs k2 st ds. So that is nothing but it is integral 0 to half kxs is 1 into k2 st. What is k2 st? That is half. So it is again half ds. So it is 1 by 2 into, it is 1 by 2 into s from again 0 to 1 by 2 equals 1 by 2, sorry 1 by 4 means 1 by 2 square. So k2 xt is 1 by 2, k3 xt is 1 by p square, 2 square. Therefore what is km xt? It is km xt equals 1 by 2 power n minus 1 by the generalization. Okay. Therefore, the resolvent kernel Rx t lambda. What is Rx t lambda? Rx t lambda is sigma m ranges from 1 to infinity lambda power m minus 1 km xt. Okay, so that means it is Rx t lambda equals, it is sigma m ranges from 1 to infinity. What is lambda? Lambda is 1, so lambda power m minus 1 is again 1 into km xt, that is half 1 by 2 power m minus 1. So it is sigma m ranges from 1 to infinity. It is half power m minus 1, or means this can be rewrite as sigma m ranges from 1 to infinity 1 by 2 all power m minus 1. That is nothing but a geometric series. When m equals 1, it is 0 means 1. 1 minus 1, 0. So 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus etc. So it is an infinite sum. So it is 1 by 1 minus 1 by 2 equals 2. It's an infinite geometric series. Okay. So Rx T lambda, the Resolvent kernel or reciprocal kernel, here it is 2. Therefore, what's our solution? If the solution is of the form g of x equals x plus f of x, so it is x plus then lambda into integral a to b k integral a to b r x t lambda km r x t lambda f of t dt. Then the integral solution is, or the required solution is, g of x equals f of x plus lambda integral a to b r x t lambda f of t dt. Here f of x is x, so that means g of x equals x plus lambda into lambda is 1, that is again integral a to b r x t lambda, that is 2 into, it is f of t dt. What is f of x? X. So f of t into t means t dt, that equals, it is x plus 2 into, sorry, it is again 0 to half. So it is 0 to half 2t dt. Agree? So you can integrate it, that is x plus the integral of 2 into integral t square by 2, so it is t square only, so it is x plus 1 by 4. So the required solution is, the solution of the given integral equation is g of x equals x plus 1 by 4. Agree? So this is the method to find out the solution of an integral equation. Either it may be Wallertraum or it may be Fredholm integral equation. So this is the method that follow. Okay. Now consider another equation, that is consider an equation. Solve the integral equation g of x equals, solve another one, g of x equals, it is 1 plus lambda integral 0 to pi sin x plus t g of t dt, sin x plus t g of t dt. Clearly the given is a Fredholm integral equation with a f of x. What is f of x? Clearly f of x equals 1. Okay, lambda is lambda itself. And what is kxt? Kxt equals sin x plus t. That is nothing but k1xt, which is same as k1xt. Why? Because kxt is k1xt. Clear? Now, sin kxt is sin x plus t, so it is k1xt. What is k2xt for the inverted kernel? K2xt equals integral a to b, means 0 to pi, kxs. Kxs means sin x plus s into k1 st, k1 sin st, s plus t ds. So k2xt equals integral a to b, kxs, k2 s, sorry, k1 st ds. That equals, it is of the form sin a sin b. Sin a sin b equals half of cos a minus b minus cos a plus b. So it is integral half of integral 0 to pi. It is cos x minus t. Come on, cos a minus b, x plus s minus of s plus t, s cancelling each other. So it is cos x minus t, cos a minus b minus cos a plus b. A plus b, that is x plus 2s plus t ds. It is half of integral 0 to pi cos x minus t, cos x plus 2s plus t ds. So it equals, that means that is k2xt equals half of cos x minus t integral cos x minus t ds. That is cos x minus t into integral 0 to pi ds. So it is pi into cos x minus t minus integral of cos x plus 2s plus t. Integral of cos x plus 2x plus t is sin x plus 2s plus t divided by, with respect to ds, it is 2. From where to where? It is again from 0 to pi. So that equals half of pi into cos x minus t minus 1 by 2 into, when it is pi, it is sin x plus 2 pi plus t. What is it? So it's of the form sin 2 pi plus x plus t. Sin 2 pi plus x plus t is again sin x plus t. It is sin x plus t. Then again it is 0. So it is minus of sin x plus t. So it is cancelling each other. So what remains here? It is half of pi cos x minus t. So it is pi by 2 into half of, so this equals, that means k2xt. K2xt equals pi by 2 into cos x minus t. Okay, so it is k2xt equals pi by 2 into cos x minus t. Now you can find out k3xt. What is k3xt? Now we try to find out k3xt. Here k3xt. K3xt equals integral 0 to pi kxs, that is sin x plus s into k2st. K2st means it is pi by 2 into cos s minus t ds. So it's of the form, it equals pi by 2 into integral 0 to pi sin a cos b. It is sin x plus s into cos s minus t ds. Then it's of the form sin a cos b. Sin a cos b, it is or cos a sin b, whatever may be, then you can integrate it. Finally you have it is pi by 2, k3xt is, it is pi by 2 whole square into sin x plus t. Sin x plus t. If you integrate this one by using the trigonometric identities sin a cos b, then you can after integration we get k3xt equals pi by 2 whole square sin x plus t. Then listen, here it is k1xt. K1xt equals sin x plus t. K1xt is sin x plus t. K2x plus t is pi by 2 into cos x minus t. And k3xt is pi by 2 whole square into sin x plus t. Then try to find out k4xt. Then you can see that this k4xt equals, it is pi by 2 whole cube into cos x minus t, and so on. So repeat these steps. Then finally, what is knxt? Knxt equals pi by 2 all power n minus 1. It is either cos x minus t or sin x plus t, that depends upon n is odd or even. Okay. So after getting this, you write to the kernels k1, k2, etc. kn where n equals 1, 2, 3, etc. You can find out this horizontal kernel. It is rxt lambda. What is rxt lambda? It is sigma m raises from 1 to infinity lambda power m minus 1 kmxt. Okay, so that means, that implies it is rxt lambda equals, it is when m equals 1, it is lambda power 0, that is 1 into k1xt. K1xt is sin x plus t. Plus when m equals 2, it is lambda into k2xt. It is pi by 2 cos x minus t. Plus lambda equals, so m equals 3, it is lambda square. It is k3xt. K3xt is pi by 2 whole square into sin x plus t, plus the next term is lambda cube pi by 2 whole cube into cos x minus t plus etc. and so on. Okay, so that means this can be rearranged as, you can rearrange these functions. That is, it is sin x plus t. Take the term sin, the terms involving, consider the terms involving sin x plus t. Then together, so it is sin x plus t into, it is 1 plus, then the next term is lambda pi by 2 whole square. Okay, so it is lambda pi by 2 whole square. So you can guess the next term. Surely the next term is lambda pi by 2 whole power 4 plus etc. Okay, plus then the next term plus lambda into it is pi by 2 cos x minus t, or lambda pi by 2, here lambda pi by 2 cos x minus t is common. Lambda pi by 2 into cos x minus t. Consider the terms involving cos x minus t together. Then we have it is lambda pi by 2 cos x minus t into, it is again 1 plus, the next term is also lambda pi by 2 cos x minus t goes outside. So it is lambda pi by 2 whole square plus, surely the next term is lambda, actually the next term is lambda power 5 pi by 2 all power 5 cos x minus t. Then put this lambda pi by 2 as commonly outside. The remaining term is lambda, so cos x minus t. Lambda pi by 2 cos x minus t is commonly outside. The remaining term is lambda pi by 2 all power 4 plus etc. So that means it is sine, the terms involving these two brackets are same. So it is sine x plus t plus lambda pi by 2 into cos x minus t into what remains, it is 1 plus lambda pi by 2 whole square plus etc. So consider the term inside this square bracket. That is nothing but a geometric series having common ratio in if lambda pi by 2, if this lambda pi by 2 modulus of lambda pi by 2 strictly less than 1, then it is a geometric series with a common ratio less than 1. Then that infinite sum is, it is a by 1 minus r. Why? Because the term involving this square bracket is nothing but a geometric series having common ratio lambda pi by 2. Then only for the sake of argument we can assume it is strictly less than 1. Then its sum is a by 1 minus r. So it is a is 1. So it is 1 by 1 minus lambda pi by 2. Sorry, lambda pi by 2 whole square. Why? Because here x is lambda pi by 2 whole square. Okay. Here the common ratio is lambda pi by 2 whole square. When lambda pi by 2 less than 1, its whole square also less than 1. So a by 1 minus r, that means it is 4 by 4 minus lambda square pi square. Okay, so it is 4 by 4 minus lambda square pi square. So it is rxt lambda is nothing but sin x plus t plus lambda pi by 2 cos x minus t into 4 by 4 minus lambda square pi square. Then after rearranging it is 2 sin x plus t. It is nothing but 2 sin x plus t plus lambda pi cos x minus t into, if you multiply together with the 2, so what I get into as this one, all divided by 2 into this one, so it is 2 by 4 minus lambda square pi square. Okay. Therefore our solution is g of x equals f of x plus, what is our solution? Then our solution is g of x equals f of x plus our solution. G of x solution is g of x equals f of x plus lambda integral a to b r x t lambda